let's see example 1. Determine whether the function is proper or improper. Then if it is improper, convert it into proper function. So let's see the first one. This is proper because numerator is power of 1 and denominator is power of 2. Alright, so the power of numerator is smaller than denominator. Let's see question B. The power of numerator is 2. The power of denominator is 4. So again, this is proper function. Let's see here, question C. The degree of your numerator is 2. The degree of denominator is also 2. Therefore, this is improper. Okay, because for improper, this is when it is the same degree or numerator is bigger than your denominator. So what should we do? Let's do long division. Let's put the polynomial here, divide by the divisor. Then let's write our answer in terms of quotient plus remainder over divisor. So this is the answer. So we can see that at the end here, this is now a proper function. Therefore, when we want to do PFD later, we will take only this part here. And finally, we can combine with 1 plus the answer of PFD. Now let's see example 2. Write the partial fraction decomposition of the function. Do not determine values. Okay, so this is not determining values of A, B, C, D, and so on. This is just opening up the partial fraction. Let's see question A. This is proper because the degree of numerator is 0, degree of denominator is 2, right? So this is proper. We can straight away do partial fraction. This is a linear and this is also a linear. So write it as 2x plus 1. Another one as x minus 3. Since this is a linear, in the numerator, this is just a single constant, a and b. Let's see question B. The power of numerator is 1. The power of denominator is 3. Since the power of numerator is smaller than denominator, therefore this is proper function. So now let us further factorize. You can take out x squared and you are left with x minus 1. X squared here is repeated linear. So the first one is x, the second one is x squared. And then this is just linear, so x minus 1. And then just put a single constant up here, a, b, c. Now let's see question C. Y squared plus 1 squared. Okay, so let's see this is proper or not. Y is power of 1. The denominator is power of 4. So meaning that this is a proper function. This is irreducible quadratic. You cannot further factorize this. So let's write this as the case of rule D, repeated irreducible quadratic. So the first part is just y squared plus 1. The second part is y squared plus 1 to the power of 2. So let's write the numerator here. This is ax plus b. Another one is cx plus d. Now let's see question D. Y squared plus 4 and then multiply with y squared minus 4. Y squared plus 4 cannot be further factorized. So this is irreducible quadratic. However, y squared minus 4 you can further factorize. So this is y plus 2 and then y minus 2. So let's open up. This is irreducible quadratic. Y squared plus 4. This is linear, y plus 2, and another linear, y minus 2. For the first term, this is ax plus b. For the second and third term, this is just a single constant c, d. Now let's see for question E. The power of numerator is 1. The power of denominator is x power of 4 if you expand this, okay? So this is proper, so straight away we can do partial fraction decomposition. The first part here is repeated linear. The second part here is irreducible quadratic. So for repeated linear, this is x minus 2. Another one is x minus 2 squared. And put the irreducible quadratic here, x squared plus 1. This is just single constant, ab. And for numerator here, this is cx plus d. Now let's see question F. The power of numerator is 3. The power of denominator is 2. Therefore, this is improper function. So you cannot further doing PFD. You need to stop here and let's do long division first. So after you do long division here, so you can write the question here now in terms of quotient plus remainder over divisor. So this is it. So let's take the later term here. So this is proper function. So straight away we can do PFT. So let's further factorize. This is just x minus 1, x plus 1. So this is linear. So we can open up, this is x minus 1, and you can open up the second one, x plus 1. Since this is a linear, therefore you can just write single constant up here, a, b. So the final answer should be in this term later on, 2x plus this term also.